Recorded is rolling. So it is another Monday, January 30. So let's go over AP Classroom Kinematics 2 solutions today. You guys know tomorrow I'm going to give you guys an in-class quiz, kinematic review quiz. Do you guys want to do open notes for this too? One tomorrow? Okay, so we'll do that. Now, of course, you guys know I'm the real deal. In May, you're allowed to use this. So, I mean, definitely have this paper. Right? You probably have this if you lost it for whatever reason, it's posted to Google Classroom. So, I mean, I'm just talking about like the single paper that it gives you. Right? So, have that on hand for sure. Right? But got to know your stuff today. Right? Actually, this will be a good review as we're going through this. But if I can just hit some topics real fast, just verbally. You got those three kinematic equations. Right? Good to know those by heart or be able to navigate them at least. Right? There's linear motion and projectile motion. Remember, linear motion is just in a straight line, might be back and forth, up and down sort of thing. Projectiles, remember, gravity only pulls vertically, and then horizontally, it's just uniform motion all the way across. Okay. And also, hey, how about graphing? Right? Can you guys graph x versus t, v versus t, a versus t? Right? You guys can do that. Okay. You might even see a rotational kinematic question. You guys know if I break out a turntable? Now, if I ask a question like this, I would just ask you like strictly a kinematic question, so nothing to do with like centrifugal force, but maybe like give it a spin and it slows down to a stop. Right. Well, if it's slowing to a stop and it's some kind of centrifugal, sorry, scratch that. Oops, misnomer. We're not talking about centrifugal acceleration. There's some kind of rotational acceleration or angular acceleration involved. Right. It maybe a negative angular acceleration if it's slowing down. So how far does it turn? That could be a displacement in radians. Right. Like the same three kinematic equations, just you replace displacement in meters with radians and angle and radians. All right, so that's coming up tomorrow. So you ready for that? Now Wednesday, Thursday, I want to give you guys a full practice exam, at least the multiple choice half. You guys know the real deal in May. You get 90 minutes for multiple choice, and then another 90 minutes to do 5 FRPs. So 90 minutes is like almost exactly 2 class periods. So that'll be Wednesday, Thursday. My plan is on Friday to start going over the solutions for that. All right. So you guys good so far with what's going on this week? All right. So my other classes back on Friday created this thing that they left some over. So just put them on your desk if you want one of these. You can take it home. Actually, it's 2 things. I got a Newton's wheel on one side and Bidham's wheel on the other side. I'll show you guys how this works real fast. So Newton's wheel, if you put all the colors together, you should get white light. Okay. The colors on your phone screen, there's really only 3 bulbs that light up. There's red, green, blue on your screen. A lot of you guys probably know that. And if all 3 are lighting, what color is your screen? White. I get it spin a little bit faster.
Good morning, please pardon the interruption. We are coming to you live from Miss Nixon's room, where we are announcing the winner of the Lit Tree, which is a tree of gift cards from Literacy Week. And our winner is Logan Hernandez. Also, our other winner of some gift cards is the person who had the most participation last week, which is Natalie Rose with 13. So congratulations to Logan and Natalie. Thank you all for participating in Lit Week. And thank you so much, Travis, for arranging all of the festivities and gift cards. Have a great day, dear. Go Hawks.
All right, the other side here is called a Bidham's wheel. Now, this only works for about half the students. Like it works for me. I can see some colors, and it depends how fast it's spinning. The purpose is to show that color doesn't really exist. Like there are no like red colored carbon atoms. That's not a thing. But but whatever wavelengths of light are reflected from a surface, your eye will interpret that as a certain color. And so colors really manifest themselves inside your brain. Right? To me, it looks like the inside one is kind of a dark red. Then it goes like kind of golds and greens. Now, if I spin it a little bit faster, the colors change a little bit, and you may not see any colors at all, but you might. Okay. One more detail here is if you're watching this on video, like I'm watching the video screen, and both the Newton's wheel and the Bidham's wheel don't really work well on video because it's like frame rate, it's probably something like 30 frames per second. But in real life, as I just did this right in front of my face, like, oh yeah, it's pretty close to white, and this one I'm starting to see the colors make up. So they left some extra ones around. Those are there. If you want one, you can take it because otherwise they are orphans. And so let's switch over and look at AP Classroom.